Hello, everyone. My name is Matthew Huang. I'm helping moderate today's session. Uh, this is Valentin Merrick. He is a consultant in data science and data engineering. He works primarily in small and medium organizations and setting up infrastructure to help unlock their data value and data generated. Prior to consulting work, he worked 6 years in healthcare industry as a data scientist, and then was more centered in data transformation and designing pipelines. He then worked for 15 months at Meta as a data engineer. He started his consulting business back when and went back to the healthcare industry, specializing in data modeling, creating metrics, dashboards, and executive and business teams. Uh, Data quality controls and migrations, and his past projects span the entire lifecycle of data science journey, data ingestion, data preparation, data modeling, ETL pipelines, experimentation, design, model development, visualizations, and communication to stakeholders. So I would like everyone to welcome Valentin to this presentation. I will let you take over.
Thank you, Matthew, and hi, everyone. And welcome to this session where we're going to dive into self-service analytics, a strategy that I consider essential in the democratization of data usage in any organization today. Specifically, we're going to see how the combined use of dbt and Apache Superset can empower business users with data exploration capabilities and enable them to generate their own insights. So a little bit about me. I know Matthew introduced me, provided a great introduction. My background is actually in applied mathematics and operation research. I was initially interested in logistics and supply chain management. And I was naturally driven towards data engineering because there was a need for it. And there is an analogy between organizing the motion of physical goods, like in supply chain, and the motion of digital assets, data today. I provide consulting services to companies to help them retrieve the most value of their data, which involves many dimensions. It's just not just about the tools, it's about processes, people, team management. Today, I have 10 years of experience in data across different roles, mostly in healthcare. Then I spent a year in ad tech at Meta. And then I started consulting. I traveled for a year, actually, in 2022, after the pandemic. And I started consulting when I came back a little more than a year ago. I'm based in San Francisco in the Bay Area, but as you can hear maybe from my accent, I'm French. I moved to the Bay Area 10 years ago. So actually, we actually going to use a project that I completed with one of my clients recently in healthcare. But the business scenario that we're gonna use is applicable to many companies. So this can be generalized. So we're gonna start with a little bit of context where data teams stands today. Then I'm gonna present the business scenario itself. And then we're gonna dive into the demos. So first, how in this project we enable self-service through new tools and new processes. And then I'm gonna conclude with some lessons learned through this project and some ideas on how to scale self-service as the company expands. And before we jump in, just a little disclaimer that the views expressed in this presentation are my own, and they are not the reflection of they are not the views of my clients. So, what's the context today of data teams? So we, as data people, we are facing incrementally new challenges with new regulations and the expansion of of data assets, we need to make sure that the right people have the access to the data that they can see. So there's a lot of governance and access control policies that data teams have to deal with. Second challenge is to maintain high quality standards, because as the usage of data is growing, especially with LLM, machine learning, and even analytics, just the business intelligence that we had before, maintaining high quality is really important because it ensures that the output of the data work is also valuable. Lastly, another challenge is to maintain a certain level of standardization. So maintain definitions and models to make sure that those definitions are consistent across the whole organization. So many challenges that the data teams have to face today. Nevertheless, the impact of data team is aligned with the business goals of the organization. What I mean by that is that what we do as data people only provides value only if it improves either the product, the services, or the efficiency of the operations of the company. This is specifically true in industries where business knowledge is important, like healthcare is one of them, fintech. Another example could be environment. I listened to a great talk earlier this morning about the usage of data to improve water treatment. So in those industries, you need a lot of business knowledge to know how to use the data to provide value. And so that requires a strong collaboration between data teams and business teams. And otherwise, the risk is to end up with silos of knowledge and no impact from the data teams. Another fact is that business users have infinite questions. When you do an analysis, when you provide an analysis result, that triggers other questions. So analysis triggers the result of some analysis triggers other questions, which trigger another analysis. So this is an infinite process. And lastly, the business users don't necessarily have the abilities or tooling to analyze the data themselves and generate insights. So the consequences of that is that data teams end up with many ad hoc requests from business stakeholders. And business stakeholders are always left with questions because the data teams don't have necessarily the time to answer all those requests. And so business stakeholders are always left with questions, which means that the foundational data work can get deprioritized for data teams, which result in poor data quality, pipelines that are not maintained. And so if the pipelines if the data are poor quality, the analysis and the output of the data work loses some value, and there is a mistrust in the analysis and insights generated. So it's kind of a vicious circle because business stakeholders lose trust in the analysis, so they lose less of the data. They lose the analysis less, and again, it's a vicious circle, and the data team end up having no impact on the organization at all. And lastly, there's also this end up in an increased turnover in the technical teams because data engineers, data scientists join a team to design some pipeline, to design data model, and if they can end up just answering ad hoc requests, and this is not very motivating for them. So there's an increased turnover in the teams, and reducing further their impact. So what's a solution to that is to actually empower the business users to generate their insights, to reduce the number of requests that they provide, that they ask to the technical teams. So it's to enable this self-service approach to business intelligence, or what I called, and I borrowed this sentence from a talk that I listened to, but that I think is great. It's centralized data governance, but decentralized data consumption. Basically, centralized governance maintains data standardization of metrics and definition across the organization, so it guarantees data quality. And decentralized consumption provides business users the abilities and the skills to answer their own questions. So so we have this combination of centralized governance and to maintain a standardization and decentralized data consumption through different tools and different processes. So let's present the business scenario that I'm gonna use. So it's a very classic business scenario. So customers sign up on a website. They go through a funnel until they convert or they purchase something. So it's a classic funnel analysis, and we want to understand basically the customer journey, the customer experience in the sign-up process, to understand where the friction happens and what prevents them from converting in the end. And we want to understand that experience across several dimensions that are specific to the business. In our example, the website of the company is a company providing medical assistance to patients with severe conditions. And the customers are patients. They can be referred on the website by their primary care physician, their health plan, or also they can be just self-referred, so they sign up themselves. And the dimension that we are interested in looking at is the sales representative, the health plan that they subscribe to, or the cohorts, by which I mean the time that they were first identified as potential customers. So the funnel looks like this. So once the patients are identified, they go through a screening process where they are assessed whether or not they are eligible to the products that the company offers. Once they are assessed eligible, they are enrolled. And once when the treatment is done, they are discharged. So, and we want to understand again the customer journey through all those steps. So when I joined, I wanted to. This is what the structure of the company looks like. So we have a clinical team, nurses, physicians that provide assistance to the patients. So it's about 150 members of that staff. Then we have the sales team responsible to reach out to potential patients and health plan to attract patients to the website. We have a business intelligence team that's responsible to answer analysis requests from the sales teams and the clinical team. And lastly, we have the tech team, which are about 10 engineers and one data scientist. Me. And so this is the key point here is that the business is much larger compared to the tech team. So we need to find a scalable way to answer the request for data insights and data analysis. So I wanted to present the tech stack when I joined. So this is this is a high level schema, but I wanted to highlight the main components for the topic we're discussing. So we have two databases, Salesforce and MySQL, and those databases are synchronized with Airbyte through a Redshift instance. And it's a pure copy, so the data is in a raw format. When we had analysis request, we exported CSV out of the Redshift instance, and we use Looker as a visualization tool. And lastly, as an orchestration, we have several jobs, and this is not used in the schema, but it's going to be important from what I'm going to talk just after that. We use Daxter as an orchestration tool. This tech stack was working, yet it was unscalable. The reason is that it results in a siloed and very rigid organization. The reason is that the data in a raw format required some transformation to be usable. So you needed some data processing skills to be able to use the data in the raw format. So the business stakeholders couldn't use that data as is. And the second thing is that when you had a request for analysis, you needed to export CSV out of the Looker instance, out of the Redshift instance, and then use Looker. And that resulted in a very rigid organization that did not provide enough flexibility for all stakeholders to explore the data sets. So to do that, enabling self-service is not just about what I mentioned. It involves like the tool in place. The tools in place are just one aspect. So we put in place new tools and new processes. So about tools, we introduced the use of dbt to transform the raw data into usable data sets that were analytics ready. And the second tool that we introduced is Apache Superset, which had some really nice features to provide business users with the ability to explore the data sets themselves. And for the processes, we provide detailed documentation about how to use Superset to business stakeholders. We define clearly the ownership of each step because there is some transition points between the tech teams and the business stakeholders. And we made sure to maintain a constant communication between business and tech. Again, to ensure that the requirements of the business teams were fulfilled by what we put in place. This is what the new tech stack looked like. So as I mentioned, we introduced dbt. And we use it to convert raw data into analytics-ready data, or what we call goal layer in the medallion architecture. And we use Daxter to orchestrate the dbt jobs 4 times a day. And then we replaced Looker with Superset as a data visualization tool. The reason is that it has many parameters that enable the business stakeholders to explore the data sets. So now let's go through each of those tools and what we did specifically to put them in place. So first, let's start with DBT. So DBT in a nutshell stands for Data Build Tools. It's basically software development for data teams. It introduces testing and version control. So it's software development for data teams. It contains several key concepts. So the main concept is the concept of model. Models are transformation from raw data into analytics-ready data sets. Those transformations are mostly written in SQL, and that's the attractiveness of DBT. It's because most of the transformations are SQL, and so only requires SQL skills. However, I've seen recently DBT model in Python, but it's mostly in SQL. So that's the main concept. Model and the main concept. We have other concepts like snapshot. Snapshot allows for time traveling because it shows the state of the dataset at a given point in time. We have the concept of seeds. Seeds, I'm going to talk about that in a few slides, but seeds are CSV files that you can use and reference as tables in the models. Then you have data tests, which are queries to test the models that guarantees data quality. You have sources, which are names provided to the source data used in the transformation. And then you have macros, which are reusable blocks of code that you can use in all of your models. So how do you set up in a DBT project? So it starts with the DBT folder, and at the root of the project, so the documentation of DBT is very detailed, but high level, at the root of the project, you have two files, two YAML files, dbt project.yaml, which provide a name to your project, the profile to use, and the path where your model, your analysis, your tests, your seeds, your macros, different concepts live, and where your target lives. So this is a configuration file. Second, you have a profile YAML file, which tells DBT how to connect to your destination database. So it provides the database name, the credential. It's a playbook on how to connect to your target destination. So again, DBT has a folder, and that folder is structured with each of the concepts that I talked before. So you have for instance, one folder containing the models. So the models folder contains all the code guiding all the SQL code guiding the transformation. One SQL file in this folder produces one table in the warehouse. And then again, I wanted to talk about seeds. Seeds are CSV files that you can reference as tables in the models. And the use case is mostly static data that doesn't change often. And for instance, here, as you can see in the screenshot, you have this diagnosis acuity CSV, and that CSV file contains some diagnosis codes that we use in healthcare. Those codes don't change only once a year. and I wanted to use those codes in my model. So I put the CSV file in the seeds folder, and I can reference the CSV folder as a table in my model to use the diagnosis codes. Lastly, as you can see, I highlighted here this sources.yaml in the model file. This source that specifies the source data that the DBT model can use. For each source, you need to add it to that sources.yaml file. So what kind of sources can be used in DBT models? First, you can use source tables. And in our case, that's the table in the data from Salesforce and MySQL that were copied in the Redshift instance in its raw format. So those tables can be used as sources in DBT file. So again, the names must be provided in a source.yaml file. You give a name, in that case, enrollment. You give a name to the table, for example, patients, and you reference those sources in the model files with their names. So I provided an example here. You put from source, open parenthesis, enrollment, comma, patient. Then you can use, as talked before, you can use the seeds in your model, and that works the same way as source tables. The names must be provided in the sources.yaml, and so in that case you have the name is analytics, the name of the table is diagnosis acuity, and you reference those seeds table in the model files in the similar way as tables. So it works exactly the same way. Lastly, another source that you can use is another model. So in that case, the output of a previous DBT model. In that case, the names don't have to be provided in the sources.yaml file, and you reference another model in the model file you want to use them with these names. So you put ref, open parentheses, the name of the model, and you can use any model. And I mentioned earlier that we use Daxter as an orchestration job, so as an orchestration tool. So if you look at the lineage of a Daxter job of a model that depends on the model, you can see in Daxter this dependency between the two models. So I also wanted to talk lastly about materialization. So the documentation on materialization is very detailed, but it has, I put the link at the bottom of the slide here. So there are several types of dimensions: views, tables, incremental, materials views, but the two main ones are tables and incremental. And so tables are basically rebuilt at each run, and the advantage of that is that they are really fast to query, but the downside is that they can take a very long time to materialize, especially for complex transformations. On the opposite side, we have incremental. So incremental materialization enables DBT to process only new records. The advantage is that reduces the running time, but the downside is that requires some advanced config in the model. And I included some sample code here. For instance, you use the macro is incremental, which means that the table already exists, so it's an incremental run. And you can see that from the code that on incremental run, the where statement actually makes sure that only new records get processed by the incremental run. Finally, you should pay attention to permissions, and you should make sure that in the dbt project.yaml that permissions are not removed after each run. And I wanted to highlight that issue because that's an issue we've run into. At the end of each job, basically the permission were removed, and so the user did not have access anymore to the output of the dbt model. So to prevent that, in the in the project.yaml, you need to make sure to grant permissions to the right user after each run, and that's the sample code, like the config that I included, is a way to do it. You need to make sure that the select permission is granted to the right users. Okay, so now we put in place dbt, and before we move on to Superset, I wanted to take a break here, make a pause to see if there is to take any questions. And I'm going to also leave question at the end. So
yeah, jump back in to see if there was any questions. I don't see any in QA. Rija asked if there was a way that you could provide the slides.
Yes, so you can connect with me on LinkedIn, or I can send the PDF at the end of the session here. I'm going to send in the chat the PDF version for those who want.
Awesome, and I think I put your LinkedIn at the very top of chat, so
okay, perfect.
If people are looking to connect with you, they can do it that way.
Yeah, perfect. Thank you.
Yep.
So I'm gonna continue the presentation and move on to Superset now. So Superset is a data visualization tool born out of Airbnb in 2017. It's open source, and it's based on three core concepts: datasets, charts, and dashboards. Basically, charts are based off datasets, and dashboards are a collection of charts. So let's start with datasets. So datasets can be created from source tables. So the source tables in that case are the output of the dbt jobs that I mentioned earlier. And the way to do that is that you go on the Supersets tab, you go to datasets, create datasets, and you can select the source table. In our case, it's from that Redshift instance, and so where the output of the dbt model lives. And the second way is also to define a custom SQL query. So, which is nice about Superset, because you can either directly take a dataset that is ready for people who don't have necessarily the skills, or you can define your own dataset using SQL for the more technical savvy people. So there's two ways, and once you define either your source table or your SQL query, you click on Create Datasets, and it prompts you to create a chart out of these datasets. Datasets are transition points. This is where, what I mean by that is that this is where the transition happens between the centralized governance and the decentralized data consumption. The reason is that on datasets, you can define metrics that are proper to the datasets, and you can see here, I edited the datasets, and you have metrics, the label of the metrics, and the SQL expression that define those metrics. And the fact that they are proper to the dataset, that guarantees standardization and integrity of how those metrics are used in any chart using these specific datasets. So that guarantees standardization and integrity. And the second thing about the assets is then you can control who has access to these assets. So who can modify it. So who can modify, for instance, the metrics that I just mentioned. So here you can, again, you can edit the owners of the assets, and those people will be the only one allowed to modify the assets. So this guarantees governance and standardization. And as I said, it's a transition point because the charts is where the customized data construction starts. Customized, I'm mentioning customized data consumption is because on the charts, the metrics used on the charts can be specifically defined for the charts or taken from the dataset itself. So, for instance, here you can use on the left, you can see that you have all the metrics defined to the datasets, but on the right, in the middle, sorry, you can define specific metrics for the chart. So again, if you want to use the metrics and you don't know how to define new metrics, you can take them from the datasets. But if you're more like you have more technical skills, you can define new metrics as you're making your charts. Finally, so dashboards, which are a collection of charts, enables data exploration. And I wanted to highlight a really nice feature of dashboards that allows for data exploration. It's the fact that you can configure filters to slice the data displayed. Often, business stakeholders have infinite questions, as I mentioned earlier. And to answer this question, you can predefine filters that enable them for a single dashboard to slice the data displayed across key dimensions. So to do that, you click on the blue arrow on the left. And here you end up with the filters that correspond to the main dimension that you want to slice the data by. And to add a new filter, you just click on Add Edit Filter, and you have a lot of configurations that you can use to predefine this filter. So that's a really nice feature because that allows business stakeholders to slice the data by the dimension that they care about. So you make your data set, then you have charts, and then you make a dashboards and business stakeholders can slice the data on this dashboard. But it's not over. It's again enabling self-service is not just about tools. Once you set up the right tools, you should not forget about putting in place the right processes and keep communicating. So in our case, what we did was that we wrote a user guide, very detailed, about Superset to enable business user to use Superset and to know how to explore data in the dashboards, even to make new charts. And so we wrote a very detailed user guide. And the second thing we did was to maintain constant communication and to gather the feedback. And this is really key to make sure that we maintain a level to make sure that what we did as data people still fulfill the requirements of the business stakeholders. So the result of that project it was a success because since we started we have been starting that for 3 or 4 months, and since then 40 data sets have been created, 115 charts, and 12 dashboards. And we have usage across clinical teams, sales, business. We have usage across all teams. So that is so far a success to enable all teams to explore the data. So to conclude the talk, I wanted to go over some lessons learned over this project. So the first lesson is that you should focus on setting up good practice very early. What I mean by that is that it's very easy for data teams to and very tempting to focus on delivering results. So answering ad hoc requests can be tempting because you're actually delivering results. However, in the long run, it will penalize the org if you don't put in place the right processes and tools early. So you should focus and give time to set up good practice and processes as early as possible. Second lesson is that you should choose the tools and processes that best fit your use case. In our case, we use dbt and Superset, but I'm not saying that Superset is not for instance, so dbt is largely used, but it's not the only answer. Superset is one visualization tool across many. I know that there is other data loss for search service like Metabase, for instance. I've not looked into it, but I've heard of it. So what I wanted to say is just that there is no right answer, and you should each use case will have different tools, and so you need to do a benchmark of all the tools available before and choose the one that best fits your use case. Lastly, I wanted to mention some ideas on how to scale as this self-service approach as the company expands. This is more a suggestion slide and ideas on how to enable self-service for larger companies. So the first is to introduce like data champions to business teams, and that's an idea that I borrowed from that GitLab put in place. GitLab has a lot of resources on how they structure their data teams, and they introduced data champions. So those people are members of the business teams. They are decentralized, but they are responsible to maintain the communication between the centralized data platform team and the business teams, and that ensures that the requirements of the business teams are still matched. Another idea is to insert the data quality checks very early in the pipeline, and you need to do that early. That maintains trust in the analysis produce, and so that increases the confidence that we have in the insights generated, and so that increases the usage of the data across the organization. You should also do your due diligence and analyze the usage of charts and do periodic cleanup. Otherwise, the number of charts can become exponential, and the issue of how to discover which ones are reliable arise. So you need to make sure that the charts that don't get used often are removed, and so that all the charts that the business teams look at are actually reliable. And also talked before about standardization, but so you have a way in Superset to standardize to create metrics in proper to datasets. But as the company expands, it's a good investment to put in place an actual catalog to standardize all the metrics and the definition used that guarantees the standardization across the organization. And lastly, a final idea is that to truly enable self-service in the company, you should adopt I think one should adopt a product approach to your data strategy. So we are seeing the more and more data product managers, because if you enable self-service, that's an internal product that you're making. So you should have this product approach when you design a system that enables self-service. So yeah, again, adopting a product approach to the strategy is really key in enabling self-service as the company grows. And that's the end of my presentation. I thank you everyone for listening and staying in. And I'm gonna leave the rest of the time for questions.
Valentin, thank you so much for sharing. That was a great project to kind of go over. We'll start with first question from Christopher. I think you kind of answered it, but his question is, what was the primary reason behind using DBT versus some other methods stack?
So we didn't have any data transformation tool, and DBT seems the most widespread tool and the is more easily accessible. So we had the technical team is quite stretched. We have 10 people, and the documentation of DBT was is very detailed. It requires only some SQL, so it was really fast to deploy DBT and to set up the project. So that's the primary reason for using that.
Sure. This is kind of my own question, but DBT feels like it's very widespread in Silicon Valley and kind of like in the tech industry. But like, I'm from Columbus, Ohio, so it's nowhere near as widespread here. I don't even know a single business here off the top of my head that would use DBT.
Okay.
So not really a question, more of a comment, but just interesting.
Yes. Yeah, I've seen many stacks that use DBT, and from the example that I've listened to, so DBT seemed quite known, and the attractiveness of DBT again is that it's primary. Why people turn to DBT is because it's mostly in SQL, and so it enables like data analysts to write their own transformation. It doesn't require like software engineering skills.
Yep.
And it's a good way to transform raw data into analytics, like data sets that are ready for analysis. So more like summarized tables.
Sure. We'll go on to the next question from Raul. Did you use cloud versions or self-hosted?
We use cloud version, DBT Cloud.
Sure. And then another question from Raul. I think you also talked about it on one of your slides, but what are some of the challenges in deploying the stack?
Like for DBT, it was new for me too, because I've worked at Meta before, so we didn't use DBT, so we had our own tools. And before that, DBT was not really. We didn't use DBT in my first company, in the company I worked for. So it was learning about the different config, I would say. Not about the transformation themselves, because it only requires SQL, so it's very easy, but the config, I mentioned earlier, the small issues that arise when the permission issue, after each run, we didn't have permission. So how the config to put in place to prevent those permission issues. So that requires some the syntax that require like some attention and detailed reading, I would say, of the documentation. And then we otherwise for DBT it was quite straightforward. For supersets, in terms of deployment, there was no technical issue here. I would say most of the issue were more on the usage side. We needed to make sure that business users were actually using supersets and had the ability to use it. And so it was more about communication. But in terms of technical deployment, there was no real challenge here, I would say.
Yeah, I think most data visualization tools kind of have that challenge, whether you're in Power BI, Tableau, Superset, Google Looker. It's getting the business user to kind of understand how to use the functionality within it, right?
Yeah, and one key aspect is really to maintain communication, I would say.
Yep. Raul and Christopher went back and they talked about other alternatives, SQL Mesh, Snowflake, and then Rija also asked, like, can you briefly compare DBT with Snowflake? I am thinking of using DBT for a project and would be great to have your thoughts.
Well, well, it depends on how you want to. It depends. So DBT is really a transformation tool. It's not a Snowflake Snowflake has a lot of offering, right? Snowflake is more like first is the data warehouse, the cloud data warehouse. So it depends on how, Christine, you want to use Snowflake. It's sorry, Rija, sorry. So there's no really comparison to be made between DBT and Snowflake. Snowflake, I would say, Snowflake is a huge like it's a whole framework. It offers everything. It offers like data transformation, data warehouse. You can train algorithm. It's a whole platform. Versus DBT is just a transformation tool, and it's very easy. So to start a project, I would use DBT because that's the quickest way to get. You can transform data from a MySQL or any instance into datasets that are ready to analyze using DBT, and that's very quick to set up. Versus Snowflake, I think require more advanced config, and so the learning curve would be steeper for Snowflake, I would say, than for just DBT. So I would to start a project, I would use just DBT because it's the quickest way to get started.
Awesome. Yeah, even when I went to go learn Snowflake, I already had a background in Oracle and Teradata and Microsoft SQL Server, so I already had a change between PL SQL and T SQL. And then when I started doing Snowflake, I was like, another SQL syntax I have to learn.
Yeah. So when you move on to, I know the Snowflake, there's also Databricks today, which offer like similar. Like they move on to the same space. Basically, they eat on each other's feet. But learning in syntax is not hard. I think what you need to learn is the core concept, like SQL. Once you know SQL, moving on to one syntax to another, it's just one framework to another is not hard. What you should learn as data engineers is modeling, how to model a business scenario into a data model, make sure your model works. And even DBT, it's a tool, but it's not hard to learn. Once you know SQL, setting up a DBT project is not tough.
Yep. And Kristen even goes on to say, as a data analyst who migrated all of our data from Redshift to DBT, I'm a strong advocate for DBT. It makes it so easy to manage data models. So
yes,
definitely to your point.
For sure, yeah. And I know, there are to go back to Raul's question, there are alternatives, like SQL Mesh is one of them.
Mm-hmm.
And I think that the reason SQL Mesh allows to combine, they have a project for those who develop SQL Mesh, allows for SQL and Python, so it offers more flexibility to the transformation that you're making. So yeah, it's an alternative. It's less widespread, and I honestly can speak for it because I've not used SQL Mesh. Again, we used DBT because it was the fastest way to get us to what we needed, and it was again just it required some SQL. But I think as a second step, if the business case, if our use case required to use SQL Mesh, we would think about moving on. But to start, DBT is a great. I think it can handle a lot of use cases.
Awesome. Well, do you have any final thoughts before we end the session here?
No, again, as I mentioned, I think the key point here, I presented like a case study on it's more the use of DBT and Superset to enable self-service. As I mentioned, there is no one single answer. There are other tools that you can use, but allowing for, I think the key points here are a data visualization tool that allows for exploration, and Superset is one of them because it has many parameters. And the other point is to enable to have data sets that are analytics ready, that are in the gold layer of the medallion of architecture. So, and to do that, you need a transformation tool, and DBT is one of them. So, but the key aspect to enable self-service are data sets that are analytics ready, so that makes sense for business stakeholders, and a tool that allows people with less technical skills to explore those data sets. So those are the two main components.
Awesome. Well, I'll post your LinkedIn in here one more time. If you're interested in...
Let me share let me send the PDF.
Sure.
In the chat also, and I don't know if people.
So thank you everyone in chat for hanging out, and thank you, Valentin, for your awesome presentation.
Thank you. And I just send the presentation in the chat. Thank you, everyone. Thank you.
Thank you.